Hi guys! Today we're going to look at how to detect whether game objects are on screen or not. We'll make sure that the player is blocked from leaving the screen bounds. If the enemies wander off screen, we'll make them wander back into view. And when the bullets leave the screen, we'll destroy them. Okay, we'll start with this scene that has several enemies that wander around and chase the player if it gets too close. The player can also fire bullets and kill the enemies. We created this in our 2D top-down shooter series, so take a look if you want to know how it was done. Alternatively, you can download this project by supporting us on Patreon. All the links you need can be found in the description. Okay, let's start by preventing the player from leaving the screen. We'll go to the Player Scripts folder and open the Player Movement script. At the moment, we set the velocity of the rigid body based on the input. To stop it going off screen, we're going to set the velocity to 0 if the player is going to go off the edge. We'll add a new method to do this. We'll call this new method just after we've set the velocity. Now, to be able to populate this method, we're going to need to get a reference to the game camera. That's because it's the game camera that decides what's on screen and what's not. It takes the world position of the game objects and converts them into a screen position. Let's add a private field for the camera. Then we'll initialize this in the awake method. We can get the main camera by using camera.main. Next, we'll use the camera to determine if the player is still on screen. The position of the transform will give us the world position of the player. We need to convert this into a screen position to know where it is on the screen. Fortunately, Unity has an easy way to do this. We'll use the camera world to screen point method. We'll pass in the position of the player to convert it to screen coordinates. If either the X or Y value is outside the screen bounds, then we know the player has gone off the screen. First, we'll check if the X value is less than 0. This would mean that the player has gone off the left side of the screen. We'll check if we're currently trying to move in that direction by checking if the X value of the velocity is less than 0. If we're out of the left side of the screen and we're trying to move left, then we want to stop the X movement. We'll set the velocity to have a 0 value for X, and we'll leave Y at the current value. We also want to do this if the player has gone out of the right-hand side of the screen. To do this, we'll add another condition to the if statement. We'll check if the X value of the screen position is greater than the width of the screen. We can get the pixel width of the screen from the camera. This would mean the player has gone out of the right-hand side of the screen, so we'll also check if they are trying to move right. So now the player movement will be blocked if they try to move out of the left side of the screen, or if they try to move out of the right side of the screen. Let's do the same for the top and bottom. We'll copy and paste the if statement. Then we'll change all the X values to Y. And we'll change pixel width to pixel height. So this is checking if the player has gone off the top of the screen and is moving up, or if the player has gone off the bottom of the screen and is moving down. If this is the case, we want to stop the Y movement. We'll set the velocity to have the same value for X, and we'll set Y to 0. Let's save this and switch back to Unity to give it a try. Now the player can't completely leave the screen. Half of the player goes off the screen though. This is because when we check the screen position, we're checking against the center position of the player. Let's stop the game and switch back to the script to fix this. What we'll do is add a configurable screen border to check against. We'll add a serializable float field to hold the screen border value. Then, when we check the screen position of the player, we'll take the screen border into account. Rather than checking if the X position is less than 0, we'll check if it's less than the screen border. So if we set the screen border to 30, this would check if the player is 30 pixels from the left side of the screen. When we check if the player is off the right side of the screen, we'll minus the screen border from the screen width. Then we'll do the same when we check the top and bottom. Let's save this and switch back to Unity. We'll select the player in the hierarchy and set the screen border to 30. Let's give this a try. Now the player is completely kept on screen. Next, we'll do a similar thing for the enemies. Let's stop the game, go to the enemy scripts folder and open the enemy movement script. We'll add a serializable screen border field. Then we'll add a private field for the camera. We'll initialize this in the awake method using camera.main. Then we'll add a new method to handle the enemy going off screen. For the enemy, rather than stopping them moving, we're going to change the target direction if they go off screen. So we'll call this new method as part of the update target direction method. As most of the code is going to be the same as the player, we can go back to the player movement script and copy the logic. Then we'll paste it into the new method for the enemy. Instead of checking if the enemy's velocity is in a certain direction, we'll check the target direction instead. So this is checking if the enemy has gone off the left side of the screen and the target direction is to the left, or if the enemy has gone off the right side of the screen and the target direction is to the right. If the enemy has gone off screen, we want to tell it to come back. To do this, we'll set the target direction. If it's wandered off screen to the left or right, we can tell it to come back by reversing the X direction. We'll set the Y direction to be the same as before. We'll then do the same for the checks against the top and bottom of the screen. If it's gone off the top or bottom, we'll reverse the Y direction. OK, let's save this and switch back to Unity. We'll go to the prefabs folder in the project panel and select the enemy prefab. We'll set the screen border to -30. This will allow the enemies to wander off screen by 30 pixels before turning around. Let's press play to try this out. Now the enemies come back if they go off screen. If we switch to the scene view, we can see them turn around. The final thing to check the screen bounds for is the bullets. At the moment, if a bullet goes off screen, it just carries on forever, and we can see more and more bullets being added to the hierarchy. Let's stop the game to fix this. We'll go to the player scripts folder and open the bullets script. We'll add a field for the camera. Then we'll add the awake method and initialize the camera using camera.main. Next, we'll add a method to destroy the bullet if it's off screen. We'll get the screen position of the bullet using the camera world to screen point method. Then we'll check if the X position is less than 0 or if it's greater than the screen width. We'll also check if the Y position is less than 0 or greater than the screen height. If any of these conditions are true, then the bullet is off screen and we want to destroy it. We'll do this by calling the destroy method, passing in the game object of the bullet. Now we just need to call this new method. We'll add the update method and call it from here. This will check whether the bullet is off screen every frame. OK, let's save this and switch back to Unity to give it a try. If we look in the hierarchy, we can see the bullets are now being destroyed when they go off screen. So now the player, enemies and bullets are all taking the bounds of the game into account. In the next video in this series, we'll create a reusable health system that allows the player to take damage from the enemies. We'll also add a health bar to the UI so that we can see how much damage we've taken. If you want to be alerted when this one's out, then subscribe and click the bell icon. If you have any questions or feedback on this video, then please let us know in the comments. A big thank you to all our patrons, we really appreciate you helping to support the channel. If you'd like to help and also get access to the source code, you can find details in the description. Thanks guys!